High-voltage linemen are responsible for erecting, stringing, and repairing electrical transmission towers, often working at heights of 250 feet or more. These towers carry energized power lines, sometimes operating at voltages as high as 765,000 volts. This work demands specialized knowledge, skills, and a strong commitment to safety. Linemen must understand the principles of electricity, including voltage, current, resistance, and power. They must also be proficient in the use of tools and equipment designed for high voltage work, such as insulated gloves, hot sticks, and bucket trucks. Safety is paramount in this profession. Linemen undergo extensive training to learn how to work safely around energized equipment. They follow strict procedures and use personal protective equipment to minimize the risk of electric shock and other hazards. The training programs cover topics such as electrical theory, grounding techniques, safe work practices, and emergency procedures. One essential aspect of working with high voltage is understanding the concept of electrical potential difference, also known as voltage. Voltage is the driving force that pushes electric current through a circuit. The higher the voltage, the greater the potential for electric shock. Therefore, linemen must be aware of the voltage levels they are working with and take appropriate precautions. Another important concept is current, which is the flow of electric charge through a conductor. Current is measured in amps. The amount of current that flows through a circuit depends on the voltage and the resistance of the circuit. High currents can cause severe burns and other injuries, so a lineman must be careful to avoid contact with energized conductors. Resistance is the opposition to the flow of electric current. It is measured in ohms. Every material has some resistance to the flow of electricity. Conductors, such as copper and aluminum, have low resistance, while insulators, such as rubber and plastic, have high resistance. Linemen use insulators to protect themselves from electric shock. Grounding is a critical safety technique used to prevent electric shock. Grounding involves connecting a metallic object to the earth, providing a low resistance path for current to flow in the event of a fault. This helps to prevent voltage from building up on the object, which could create a shock hazard. Linemen use grounding clamps and cables to ground equipment and structures before working on them. Hot sticks are insulated tools used to work on energized equipment from a safe distance. These tools allow linemen to perform tasks such as tightening connections, replacing insulators, and installing jumpers without directly contacting energized conductors. Hot sticks are available in various lengths and configurations to suit different applications. Bucket trucks are aerial lifts used to access high-voltage equipment. These trucks have insulated booms that provide a safe working platform for linemen. Bucket trucks are equipped with various features, such as hydraulic controls, outriggers, and communication systems to enhance safety and efficiency. In addition to safety knowledge, linemen need to know about the equipment that they are using, for example, transformers. Transformers are used to step up or step down voltage levels. They consist of 2 or more coils of wire wound around a common core. The ratio of the number of turns in each coil determines the voltage transformation ratio. Transformers are essential components of electrical transmission and distribution systems. Circuit breakers are used to protect electrical equipment from overloads and short circuits. They are designed to automatically interrupt the flow of current when a fault occurs. Circuit breakers are rated according to their voltage and current carrying capacity. They are essential for preventing damage to equipment and ensuring the safety of personnel. Insulators are used to support and insulate conductors from each other and from ground. They are typically made of porcelain, glass, or polymer materials. Insulators are designed to withstand high voltages and prevent leakage current. Surge arresters are used to protect electrical equipment from voltage surges caused by lightning strikes and switching operations. They are designed to divert the surge current to ground, preventing it from damaging the equipment. Surge arresters are essential for protecting sensitive electronic equipment. Conductors are used to transmit electrical power from one location to another. They are typically made of copper or aluminum. Conductors are sized according to their current carrying capacity. The size of the conductor must be large enough to carry the expected current without overheating. When working on high-voltage lines, linemen must also consider environmental factors such as weather conditions and terrain. Rain, snow, and ice can increase the risk of electric shock. Wind can make it difficult to control equipment and maintain balance. Uneven terrain can create hazards for linemen working at heights. To mitigate these risks, linemen receive training in weather awareness and hazard recognition. They also use specialized equipment, such as insulated rain gear and non-slip boots. Communication is essential for safe and efficient work. Linemen use two-way radios to communicate with each other and with their supervisors. They also use hand signals to communicate in noisy environments. Clear and concise communication helps to prevent misunderstandings and ensure that everyone is aware of potential hazards. Regular inspections are performed to identify and correct potential hazards. Inspections are conducted on equipment, structures, and work sites. Any defects or unsafe conditions are reported and corrected immediately. Inspections help to prevent accidents and ensure that the work environment is safe. Emergency procedures are in place to respond to accidents and other emergencies. These procedures cover topics such as first aid, CPR, and rescue techniques. Linemen are trained to respond quickly and effectively to emergencies. In addition to technical skills, linemen need to be physically fit and mentally alert. The job requires a high level of stamina and endurance. Linemen must be able to lift heavy objects, climb towers, and work in all types of weather conditions. They must also be able to concentrate and make quick decisions under pressure. Working with high-voltage power lines is a challenging and rewarding profession. Linemen play a vital role in ensuring that we have a reliable supply of electricity. They are dedicated professionals who are committed to safety and excellence. To become a high-voltage lineman, individuals typically complete a 4-year apprenticeship program. These programs provide a combination of classroom instruction and on-the-job training. Apprentices learn about electrical theory, safety procedures, and the use of tools and equipment. They also work alongside experienced linemen to gain practical skills. Upon completion of the apprenticeship program, linemen are eligible to become certified. Certification demonstrates that they have met the required standards of knowledge and skill. Certified linemen are highly sought after by employers in the electrical industry. Continuous learning is essential for linemen to stay up to date on the latest technologies and safety practices. Linemen attend workshops, seminars, and training courses throughout their careers. They also read industry publications and participate in professional organizations. Continuous learning helps linemen to improve their skills and advance their careers. The demand for qualified linemen is expected to grow in the coming years. This is due to the increasing demand for electricity, the aging infrastructure, and the retirement of experienced linemen. Individuals who are interested in a challenging and rewarding career in the electrical industry should consider becoming a high-voltage lineman. As technology evolves, so too does the field of high-voltage maintenance and repair. For instance, drones are increasingly used for inspections of power lines and towers, reducing the need for linemen to physically climb structures in some cases. These drones are equipped with cameras and sensors that can detect corrosion, damage, and other potential problems. The data collected by drones can be used to plan maintenance and repairs more efficiently. Additionally, augmented reality tools are being developed to assist linemen in their work. These tools can provide linemen with real-time information about the electrical system, such as voltage levels, current flows, and equipment status. This information can help linemen to make better decisions and work more safely. Another advancement is the development of new insulation materials. These materials are more resistant to degradation from heat, moisture, and UV radiation. They also have higher dielectric strength, which means they can withstand higher voltages without breaking down. These new materials can help to improve the reliability and longevity of electrical equipment. The use of smart grid technologies is also transforming the field of high-voltage maintenance and repair. Smart grids use sensors, communications networks, and computer algorithms to monitor and control the flow of electricity. This allows utilities to detect and respond to problems more quickly and efficiently. For example, smart grid technologies can automatically isolate a section of the grid that has been damaged, preventing a widespread outage. These are some of the many ways that technology is changing the field of high-voltage maintenance and repair. As technology continues to evolve, linemen will need to adapt and learn new skills. However, the fundamental principles of electricity and safety will remain the same. The job of a high-voltage lineman will always require a high level of skill, knowledge, and dedication. Moreover, there are many regulations in place that impact the work. For example, the National Electrical Code or NEC, which provides standards for safe electrical installations. The NEC is updated every 3 years to reflect changes in technology and safety practices. Linemen must be familiar with the NEC and other applicable regulations to ensure that their work is compliant. The NEC covers a wide range of topics, including wiring methods, overcurrent protection, grounding, and equipment installation. It also includes specific requirements for high-voltage installations. For example, NEC Section 310.15 specifies the allowable ampacities of insulated conductors. This section provides tables that list the maximum current that a conductor can carry safely based on its size, insulation type, and ambient temperature. Linemen use these tables to select the appropriate size conductor for a particular application. NEC Section 250.4 provides requirements for grounding electrical systems. Grounding is essential for preventing electric shock and ensuring the proper operation of electrical equipment. Linemen must follow these requirements carefully when installing and maintaining grounding systems. NEC Section 408.3 provides requirements for overcurrent protection. Overcurrent protection devices, such as circuit breakers and fuses, are designed to protect electrical equipment from overloads and short circuits. Linemen must ensure that overcurrent protection devices are properly sized and installed. Compliance with the NEC and other applicable regulations is essential for ensuring the safety of linemen and the public. Linemen receive training on these regulations as part of their apprenticeship programs. They also attend continuing education courses to stay up to date on the latest changes. The high-voltage field is dynamic, and ongoing study is paramount.